Hello and welcome to another presentation. Today's talk is on proportions. Please write this down. A proportion is when you have equal ratios. Here's an example. The ratio of aliens to humans is 3 to 4. If there are 12 aliens, how many humans are there? Well, if we know the ratio of aliens to humans, then we can write all our information down as we should. Aliens to humans is 3 to 4. And if there are 12 aliens, and I'm going to put it in the alien column, if there are 12 aliens, how many humans are there? So we know to get from 3 to 12, we need to multiply by 4. So we times 4, I'm just going to write times 4, and we know we need to times 4 over here, so 4 times 4, and we get 16. So then there's 16 humans. Okay, so this is a proportion. So it's when you have equal ratios. Please make sure you pause and write this down. Here's the next slide. A proportion is an equation, please write this down, that shows two equivalent ratios. So like we were doing equivalent ratios earlier, this is a proportion. So they are proportionally equal. Okay, you read the proportion 2 to 1 is equal to 4 to 2 as 2 is to 1 as 4 is to 2. So that's how we read this. So 2 is to 1 as 4 is to 2. Equivalent ratios, here's the definition. Equivalent ratios are ratios that name the same comparison. You can find an equivalent ratio by multiplying or dividing both terms of a ratio by the same number. So just like equivalent fractions, these are equivalent ratios. Please make sure you pause and write this down. Let's see if we can move this. It says the definition up here says the definition of equivalent ratios. Equivalent ratios are similar to equivalent fractions, like I said before. If you simplify the ratio and they are equal, then they are equivalent. So you have to make sure you simplify before you can tell if they're equal. For an example, 2 to 1 is equal to 6 to 12, because when you simplify 6 to 12, you get 2 to 1, and you can simplify it by dividing both 6 and 12 by 6. So if you divide 6 by 6, if you divide it, if you write it out, you divide 6 by 6, you get 1. And if you divide 12 by 6, you get 2. And so 6 to 12 is equivalent or equal to 1 to 2. All right, let's try another slide. So you've seen this before. Ratios 1 to 4 and 12 to 3 equivalent. 1 to 4 is in simplest form. So 12 to 3, is that equal to 4 to 1? Well, you need to divide each term by the greatest common factor, which is 3. So 1 to 4 and 4 to 1 are not the same ratio. And we said this before, they are not the same ratio because if you look over here, the order of the terms is important. So 2 to 5 is not the same as 5 to 2. Likewise, 1 to 4 is not the same as 4 to 1. All right, please make sure you are writing this down. Find the missing term of a pair of equivalent ratios. Again, you have seen this before also. So if you have 4 to 5 is the same as saying to what? Well, you have to think, how did we go from this first ratio to the second ratio? Well, we multiplied by 3. So in order to go from this second ratio to this other second ratio, you have to do the same thing. So you have to multiply by 3. And we say 4 to 5 is the same as saying 12 to, we multiply by 3, and that would be 15. So those are equivalent ratios. Here's another one. How do we go from 42 to 7? Well, do we multiply or divide? So we have to think, did we get bigger or smaller? And we got smaller, so it is dividing by 6. So 42 divided by 6 is 7. We know that is true. And so we have to do the same thing to our second ratio, second number in the ratio, excuse me. So the second term in the ratio is 54. We divide that by 6. And 54 divided by 6 is 9. And so 42 to 54 is the same as saying 7 to 9. Okay, let's try a ratio word problem together. A jar of Alien soap costs $3.50. How many packages of Alien soap can you buy with $10.50? So you have to set up what you're comparing. So one jar, we have to write this down. Please write it in your notebooks. One jar of Alien soap costs $3.50. So $3.50. And that is the same as saying, we're comparing now. So one jar of Alien soap costs $3.50. How many packages of Alien soap can you buy with $10.50? Right? So we have to figure out what we're doing. So we created a ratio of what we know. So we set up what we're comparing, and we created a ratio. So we know we're comparing one jar is $3.50. How many packages of Alien soap can you buy with $10.50? Oh, this should just be a dot. Sorry, this doesn't exist. Create a second ratio of what you know and use a question mark for the unknown number. We did that. Okay? So we need to figure out how many jars of Alien soap. So what would that be? Well, we know to get from 350 to 1050, we can do a guess and check, or we can divide. We can say 350, maybe it's, let's try 3 times 3. What do we get? We get 15, and this is 10. Oh, so it's 3. And so 1 to $3.50 is the same as saying 3 to $10.50, or $10.50. Okay, so these are now equivalent ratios because we figured that out. Okay, let's try another one. You should pause this and try this on your own. So, Holly can read 7 pages in 2 minutes. How many pages can she read in 8 minutes? So she can read 7 pages, and I'm going to label it, in 2 minutes. Okay. How many pages can she read in 8 minutes? Oh. Okay. So here's the unknown. So to get from our second term to our other second term, what did we do? Because we know both second terms in these ratios. So to go from 2 to 8, we know we multiply by 4, right? So in order to go from our first term to our other first term, we know we also need to multiply by 4. So in 7 pages, if Holly can read 7 pages in 2 minutes, then we know she can read 28 pages, because we know 7 times 4 is 28. 28 pages in 8 minutes. And that is your solution. So she can read 28 pages in 8 minutes. Okay, and we can circle that. Oh, we can circle that. Okay. Let's try another. So here's another example. So if you write a proportion for this model, we have 4 hearts and 1, 2, 3, 4, 5, 6, 7, 8 stars, 4 to 8. First, write the ratio of hearts to stars. And we know that that is 4 to 8. Next, separate the hearts and stars in equal groups. Right? So if you were writing a proportion for this model, we could say that the ratio of faces to moons is 2 to 6. Next, you can separate the faces and moons into 2 equal groups. So this is like simplifying. So you can say it is 1 to 3. So this is also very similar. So we can separate the diamonds and the spades into different groups. So we can say it's 3 diamonds and 6 spades. Right? So there's 1 diamond for every 2 spades. So 3 to 6 is the same as saying 1 to 2. All right? And if you triple the pattern, there will be 9 diamonds and 18 spades. So this is just creating equivalent ratios or proportions. Okay, let's try another problem. So if you are creating an equivalent ratio for triangles to hearts, we know that there are 3 triangles and there are 9 hearts, right? So if there are 1 triangle for every 3 hearts, well, we know that because it's already split up. They already grouped it like that. There's 1 triangle for every 3 hearts. So these are equivalent. And so if you triple the pattern, there will be 9 triangles and 27 hearts. We're just saying there's not 9 triangles and 27 hearts up here, but it is equivalent. It is all equivalent. Right? So 3 over 9, 1 over 3, and 9 over 27 are all equivalent ratios, or they are proportionally the same. Okay, so here's another way of doing proportions and figuring out if they are equal. Cross products and proportions are equal. And when we say cross products, we say it like this. So we know 4 to 8 and 2 to 4 are the same. So if we multiply it across, like we went this way, 4 times 4 is 16, and we know 8 times 2 is 16. And so these are equal, all right? Just like that. Right? Okay, so we know in the second one, 5 times 9 is 45, and 3 times 15 is also 45, so these are equal. Okay, 6 times 3 and 9 times 2, they both equal 18, so those are equal. And 7 times 2 and 14 times 1, those are both equal as well. So here's another slide. If you had to complete this proportion, you can figure it out by doing cross products, right? So 5 times 18, we can figure that out. 18 times 5, because we put the bigger number on top, this is 40. 1 times 5 plus 4, that's 9. And so we have 90 on one side, and that's equal to 6 times this missing value. So we can say it's 6n, right? And so 6 times what would give you 90? Well, we can divide. So we can say 90 divided by 6, and let's see what that would give us. And that would give us 15. So we know that our missing value, so 6 times 15 equals 90. So our missing value is 15. All right, so let's try another one. So we did cross products here. This is another way you can solve it. And here they show you. Now the cross products are equal, right? Just like I showed you. So it equals, yes, it equals 15. So here we go. Let's try another one. Find the missing value in the proportion. So first you need to find the cross products. And we know that the cross products must be equal. So 5 times this missing value of n is the same as saying 3 times 15. So we rewrite it, and so we say 5n is equal to 45 because 3 times 15 is 45. And so 5 times what number will give you 45? Well, we need to divide. Okay, and so we know this missing value is then 9. This is just another way to do proportions. Okay, here's one homework. Here's your homework number 1. If there's a recipe for making 4 pancakes, here's your recipe. You want to make 10 pancakes. How much flour do you need? So please pause and do this homework. This is your first problem. And the second problem is following this. So here's the second problem. So here's your second homework problem. If you are enlarging a poster, the photograph is enlarged to make a poster. The photograph is 10 centimeters wide and 16 meters high. So part A, the poster is 25 centimeters wide. How high is the poster? And part B, the building on the poster is 30 centimeters tall. Is it possible to figure out how tall the building is on the photograph? If you think it is possible, show how. If not, explain why. All right, and I will see you tomorrow.